from this question, we can also be asked to get the magnitude of the resultant. Okay, and we can also ask to get the direction. When I say direction, that means the theta, okay, of the resultant. Yeah. Now, but before the direction, let's talk about the magnitude. Okay, magnitude is symbolized with this sign. Okay, this is the sign for magnitude of a particular vector, and you know we are talking about resultant here, so that's why we are having r, magnitude of r, so which equals to square root 3 raised to power 2 as in square plus 4 square. Okay, so which equals to square root 9 plus 16, which equals to square root 25, which equals to 5 minutes, right? 5 minutes. Okay, alright, so this is the magnitude of this vector. This resultant vector is still another vector. You should know that it's just the summation of two vectors that's giving us another vector. Okay, good. And now, what is the direction? When we're talking about direction, mean the theta, direction of the vector. Remember from our SOHCAHTOA. I believe you are familiar with this, where we have a sine to be equal to opposite over hypotenuse, cos adjacent over hypotenuse, and tangent because what? Opposite over adjacent. Okay, from the question that we solved, you should know okay, B all right, so from here you should know that our y-axis, remember from here, this is followed by another vector of 4 units parallel to the y-axis. So we're having 4 units here. Okay, good. And remember here, consider a vector of magnitude of 3 units in the what? Direction of positive x-axis. So this is what? 3 units. Okay, and remember from SOHCAHTOA that the angle facing the side facing the angle is called opposite. Okay, then the other side is what? The adjacent. All right, now theta, this is the opposite side that we're talking about, and this is what? Adjacent side we're talking about. Good. So from tan theta, we are using tan here. Okay, tan theta equals to what? Opposite, which is vector b. Remember, vector b over vector a. Okay, now our tan will be equals to what? Our tan will be equals to tan, our theta rather will be equals to tan inverse of 4 over 3. Okay, so tan inverse of 4 over 3 will be equals to 33.1 degrees. Do you understand? So that's how we get our direction. Okay, good. So our theta equals to tan inverse of 4 over 3, which equals to what? 53.1 degrees. So that is that on the magnitude of vector and what? Direction of vector. So alright, so welcome back. This is vector multiplication. And under vector multiplication, there are 3 methods in which we can use to solve questions relating to multiplication or product of vectors. Okay, we have number 1, we have dot product. Okay, number 2, we have cross product. Okay, and number 3, we have triple product. But for For this class, we will be talking about dot and cross products. The other one is beyond the scope of this class. Dot product is also termed scalar product. Note that. Alright, and cross product is also termed vector product. Alright, so we'll be taking them one after the other, and I want you to follow through. Alright, dot product. Now, vector A dot B equals to AB cos theta. Alright, do you get that? Vector A dot vector B equals to AB cos theta. This is for dot product. But for scalar, for cross product or vector product, it's called vector A dot vector B. Sorry, cross. This time is now cross. Not equals to A B sine theta. Do you understand? So that's the difference between the vector product and the cross product. Note that this is the vector product. Okay? Vector. Alright. This is for vector product. We have A cross B to be equals to AB sine theta multiplied by the what? By the unit product. This N here having a cap is called the unit vector. Alright, good. So we're starting with this. Let's pick an example. Alright, good. Let's say vector A to be equals to 2I plus J minus 3K, and vector B to be equals to 3I plus 2J minus 4K. Alright, so we are trying to get the product, the dot product of these two vectors. Now, one thing I want you to know before we actually continue with this example is that, note, I dot I will always give you 1. Okay? J dot J will give you 1. K dot K will give you 1. Why? Because these are called unit vectors. Alright? These are called unit vectors. So, and once they are actually multiplying themselves, they will give unit result, which is 1. But when you are now multiplying I dot K, this will give you 0. Okay? Or you are multiplying J dot I, it gives 0. Or let's say J dot K, it also gives 0. When they are actually different, when you are multiplying two different units together, they give what? 0. That's what? Under dot product. Do you get that? Under dot product. Okay? But under dot product, if you are having this, having two unit products, the same unit product, multiplying each other, they will give what? 1. Do you understand that? Good. Alright. Now, having said that, let's come back here and solve our example. Good. Okay. We want to solve for A dot what? Dot B. Alright, good. 2I plus J minus 3K. Okay? Dot 3I plus 2J minus 4K. Right? Good. Now, recall what I said here. That you can only get 1 if you are multiplying I dot I or J dot J or K dot K. But having multiplying I dot any other unit vector aside from I, we give what? 0. So that will just be a waste of time if we are trying to multiply 2I dot 2J. Why? Because it gives 0. So having the understanding of this, let's just solve this. on a easier level. All right, thank you. 2i dot 3i, okay, plus j dot 2j. Hope you follow. Plus, all right, minus 3k dot minus 4k. All right, this is all we are. So 2i dot 3i gives what? 6. Remember, I dot I is what? 1. All right, plus there is an invisible one here. So 1 times 2 is what? 2. I dot I, j dot j is what? 1. Okay, plus minus 3 times minus 4 is what? Plus 12. Okay, and our k dot k is still what? 1. So we are having plus 12 here, which equals to 6 plus 2. 6 plus 3 is what? 8. 8 plus 12. 8 plus 12 is 20. So you are having 20. Note, for every dot product, you must get a scalar result. For every dot product, you must get a scalar result. But for every cross product, you must get a vector result. That is why dot product is what? Is a scalar product. And cross product is what? Is a vector product. Hope you follow through. Alright, thank you. See you in the next example. Alright, you're welcome back. So we'll be talking about the direction, how to get the direction of the dot product. And recall that we said for every dot product that you solve for, you are getting a scalar result. And what do I mean by a scalar result? A result without having the I or j. Okay, so you can see that this 20 is standing alone. This is what? Magnitude without direction. Alright, so to get cos theta of this question, we have cos theta to be equals to a dot b all over magnitude of a, magnitude of b. Okay, so good. A dot b, we've gotten our a dot b to be what? 20. Yeah, okay, that's what? 20 all over. Now, magnitude of a, recall from the previous example that magnitude is what? Magnitude is square root of ax I squared plus ayj squared plus az k squared. Recall from the other time. Alright, so now we can also apply it here. We are having 2 square root of 2, okay, squared plus 3 squared plus what? Sorry, not 3 now. 1 squared plus 3 squared. Okay, so dot square root of, that's for b, 3 squared plus 2 squared plus 4 squared. Alright, so which equals to 20 all over, this is 4 plus 1 plus 9, 10, 14. So square root of 14 dot square root of 6, 9, 4 and 16. So 4 plus 16, that's 20. 20 plus 9, that's what? 29. So this is cos theta to be equals to 20 all over square root 14 dot 29. Alright, so theta equals to cos inverse of 20 all over square root of 14 dot 29. Alright. Alright, so our theta equals to cos inverse of 20 over square root of 14 dot 29. However, the dot you are seeing here is not decimal. You know, we are talking about dot product. So that's what? Multiplication sign. Okay? Alright, good. So then cos inverse of 20 over square root of 14 times 29. So which equals theta. From calculator, you can see that theta equals to 6.98 degrees. Alright, good. Thank you.